In this video, we'll continue our exploration of SDL2 in the COBOL language. This is the beginning guide to SDL2 in COBOL. So you'll want to, if you're joining us for this video, you'll want to go to GitHub, Programming Rainbow, Beginner's Guide to SDL2 in COBOL, and you're going to want to clone that repository. Okay, so this is the second video. The first video, we just set up COBOL in SDL, and we just made a simple program, and we talked about the makefile and we compiled it. So in this video, we're actually going to open an SDL window. That's the target for this window. So I'm going to continue with the code from the last video, but if you're joining for this video, you're going to want to grab from the repository whatever code is in video 1, which was the last video, and you're going to want to copy it into the source folder. And you should have something that looks similar to this. This is just a little skeleton of a program here, just an outline. So we're going to start adding to it. I think right up here, we'll change the name of the program to open window. And we'll change it down here as well. Okay. And we're going to remove, one of these, we're going to change it to window title. And I'm going to leave it capitalized because that would be the style that I would do it in other language when I have something that's a constant. So I'm going to have a window title, a window width, and window height. And I'm going to create those here. I'm just going to repurpose this one here to be the window title. And it's still going to be pick 20, but the value is going to be slightly different. So we're going to call it open window. But I'm not going to be printing this out to the terminal this time. This time I'm going to be sending it into the SDL create window function. And since I'm sending it into that expects a C style string. That's a string that has a null character at the end of it. So I'm going to add a Z in the front here, and that's going to give me a C style null character terminated string that I can send into a C function. Okay, so we have this Z in the beginning of it there, but everything else is basically the same. For the other one, say the window width, I'm going to change it. It's not going to be a pick clause. Instead, I'm going to have a usage, and I'm going to make it a binary int, okay, with a value of 800. So the reason for this is I don't want something that is going to be used for COBOL. I want something that's going to be used for sending again into the C library. And it needs an int. So this is a binary, it's in a binary style integer, which is what I need to send into the C function. And we're going to do the same thing for indents. That's it's not the LSP, it's just the highlighter, this tree sitter, I think that's doing that. So we're going to say window height. And same thing, usage. And you're going to see this a lot. We're not going to be using these COBOL style pick clauses very much. We're going to be using these more usage, binary, pointer kind of things like that, because we are interfacing with the C library directly. And you'll see that in a moment here, how we do that. And this will be 600. So our target window size is going to be 800 wide by 600 tall. Okay, did I do all that right? Okay, so this next bit, I'm emulating the macros in SDL. So there's certain macros like SDL init everything, SDL window pause center, and we'll see those in the functions in a minute. But those are from the preprocessor. They're macros that are defined in the header files for SDL2. And we're not going to be using the header files, but I'm just going to statically define them myself here. so that I can use them in the same fashion. But I'm going to be putting in what seems like magic numbers, but I'm going to show you where I'm getting those numbers from. So if you've ever initialized an SDL window and all this, we're going to see all this happen here shortly, but you'll see that you can pass in parameters like SDL. It's going to be all capital, sorry. I have my caps lock on. SDL init, everything. Okay, and this would be, like I said, a macro. We're going to save it as a binary int because this would actually be represented as an integer in SDL. A lot of preprocessor macros, especially enums and things, are actually just ints for the C language, and we are interfacing directly with C. And after we do the second one, I'll show you where I'm getting this from. Make sure you put a period at the end of each of your sentences, as this is COBOL. And this one will be SDL window pause center. Centered. This one is 805 240. There's probably a way better way, but this is just simple enough just to do it this way. This is 832. So I'm going to show you where I'm getting this number from. So these are coming straight out of the header files. So say we have this SDL init. This is the function that initializes SDL, and it's receiving flags that are unsigned 32. Oh, they're unsigned. I don't think it's going to matter here because I'm not going to overflow it, but we can change that to unsigned. But it's returning an int, which is 0 on success or negative. So we are going to capture this return as well. But let's just talk about these flags for a second. So the flags are down here, right? And these, again, are preprocessor macros. These aren't even enums, I don't think. They're just macros. So this SDL init everything, well, if you look it up in the actual header file for SDL2, here's the SDL, oh, sorry. We're looking at the window pause, not the init, but it'll be a similar story. It'll be defined in one of the header files. So this one in SDL video.h is where the window pause one is defined. And this window pause centered is here, which is actually a wrapper for this one, which is actually a wrapper for this one up here, this masked one. And now this number right here is a hexadecimal, and it is unsigned. If we take this hexadecimal number and we put it into here, because I'm not going to be able to calculate this off the top of my head, we get this 80, 52, 40, 83, 2 number. So that's where I'm getting this number from. And it's, most of them are much simpler than this, like the SDL scan codes, and that's just an enum, so it's just in order. It's very much easier. This is the most complicated one probably, but if you don't know and you want to interface with SDL and you're not sure which exactly one, your safest bet is just going to be to look into the header file and see where it's defined, and it's going to be defined in one of the header files, which will be here. It'll be on your system, but I'm just showing you from a website. This is the GitHub for SDL. And this is the most complicated one. Most of the time, they're just enums. This one doesn't have an enum, but yeah. And enumbers are just ordered. They're just, 1, 2, 3, 4, 5, 6, 7, 8, 9 kind of deal. But yeah, so we're going to be throwing some magic numbers in, but I'm defining them separately. Well, they're not really magic. Well, I'm making constants up here for those so that I can use them in the exact same way they would be, and they're carrying the same values that they would be if we were coding this in C, so that we can pass them into the C functions and they act the exact same way. So we will have a couple of these, but most of them are going to be SDL scan codes. And like I said, they're much simpler. They're very easy to look up. You can actually just look them up on the page. We'll see those in a different video. They're not, you don't have to look in the header file for those. So the other kind of complicated thing we have going on with SDL is that we need to, if an error occurs, I need to grab that error. And that error is going to be printed, it's going to be returning from a function called SDL get error. Somewhere here, SDL get error. So this SDL get error returns a string, right? To capture the string took me quite a while to figure out, but I did figure it out because I initially had wrapper functions that were basically, I created my own little C library where I could get information in and out between COBOL and SDL2. And I didn't want to do that. So I finally figured out how to do this in COBOL. So we do need this information from this, just in case something goes wrong in SDL, we want to get the error back from SDL into our COBOL program so that we can print it out the way in the first video, we can print it to standard error the way we want to. So looking at this function, we have to kind of skip around a little bit in this first video just to set things up, but we are going to need basically a pointer, and it's going to be a couple things. So I'm going to put all the pointers in a section together. And this will be the first pointer. It will just be this error, holding our error pointer. So we'll call this, I'm just not going to capitalize. This is kind of my own variable. So on these up here, they're capitalized because they're kind of constants, but down here, these are my variables now. And I'm going to call it error pointer. And the usage of this is going to be a pointer. And we're going to set a default value of null. Okay, so that is going to set up a pointer. And before we talk about the other pointers, I want to just keep going with this error thing. So this is going to be, if we were doing this in C or SDL, I would make my own. I would use fprintf, and I would make I would just type it out. I would do something like this. I would say std error. I would do something like this, and I would say whatever the error. Say I tried to initialize SDL and it failed, so I'd say error. Say error initializing SDL2, and I'd put a colon and a space, and then I would do this. Oh, I would put another string there, and then I would say SDL get error, right? I would have something that looked like that. Basically, I'm sending it to standard error. I'm not sending it to standard output. I'm sending it to standard error. That's why I'm using fprintf. And I'm putting in my own string here, so I know if I see it crash, I know in the code what happened. So this is my part of the error message. And then here after the colon is, sorry, this should be a function call. So here after the, and the reason why this is happening is because I've passed a line here. Don't worry about that. This is C code. But I'm adding a string onto this, which is coming out of this SDL get error. So it's basically, I have my part of the error message and then the actual error occurred. So from that whole thing, I'll know what happened. So because of this, I need this part here. I need to make my own message. And then here, I need to get the error from SDL that happened. And then I need to put them both out as an error message. So because of this, I'm going to have my own error message that will just use a standard pick clause because this is going to be a COBOL thing. This is something that's staying inside a COBOL. It's not being passed to a C function or anything like that. So we'll use 77 again. I'll say error message. Now this is going to represent, like I said, the part that I typed as my error message. I will use the pick clause, and I'll give it 50 as my kind of buffer size. Whoops, that. Okay, so this is going to represent my error message right here. Now this is the pointer coming back from this, but we can't use that directly. So we still have to kind of process this coming back from C, and it was not easy to figure this out. I'm sure there's a lot of COBOL programmers out there shouting at their screen and they know exactly what to do here, but I'm very new to COBOL and I was just trying to figure out how to get SDL to work correctly and without a wrapper function. I initially did have one, but I was trying to move away from that. So this is what I came up with. So I first have a I need to find out what the length of the string coming back. So I have a buffer length. Yeah. So we'll call it error buffer len, and I'm going to say an unsigned int. I'm going to say value 1 on it. We'll see that in a minute. So usage, just make sure I'm spelling everything correctly. Okay. So the other thing that's kind of strange is in COBOL, when you're indexing things, when you're kind of indexing into their version of an array, it's 1 based. It starts with 1. So because of that, this value here is going to start with 1. And I'm going to use this to index through the string that I get back to find out where the string ends, because I need to know how long the string is that comes back. And here is going to be my buffer that holds the actual string. And this is going to be a little bit strange as well. So this one is multi-leveled. I forgot the COBOL name for this, but it's kind of like a struct. It has a name for it on the top layer, but then it has members of it that are their own data sentences, or however you want to say it. So this is 0, 1. We'll call it error buff. Yeah, we'll just call it buff. This is the buffer itself, and I'm using this word base. I'm going to be changing where this pointer points to later on, so we have to use this keyword here. And here's the thing that's inside of it. And this is going to be the array that's inside of it. So basically, I think the top is kind of like the pointer to this array, like almost like the name of it. I'm going to call this error buff array. And for this, the usage, it's going to be multi-line, but it's 1 sentence here. The usage is going to be a binary char unsigned, okay? Because we're receiving C-style string, which is a character array, and those characters are unsigned. They're 1 byte chars, they're characters, and they're unsigned. Unsigned. And I'm going to say it occurs 512 times because I just need a big buffer. I don't know how long the string is going to be. I'm trying to make it just a big enough buffer to hold it. So I'm going to give it 512. Oh, does it all fit in 1 line here? I thought I had to wrap this one. Usage. Binary char, unsigned. Oh, occurs. Yep, I do have to wrap it. So we'll wrap it here. Because there's no period, it'll just keep reading the line the same. I'll say occurs. 512 times. So this is going to give me an array that's under this name, this error buff name, but it's going to give me an array that is 512. No. Again, my COBOL skills are not that great, so I don't have the proper terminology to give you here with this, which I wish I did, but again, this is for people who may already know a bit of COBOL. So what I'm going to do is when I get this return, I'm going to capture it in this pointer. And this pointer is just the pointer to C, and I can't do anything with that. But if I take this array and I change the address of this to be on top of this pointer, now I can access that array. But now I don't know how long it is, and it's just going to print out 512 characters, and that actually might cause a segmentation fault because the string may be 10 characters long, and I'm trying to do 512, and I'm going to run into other memory. So what I'm going to do is I'm actually going to count down. I'm going to do a loop down this string that I get back, and I'm going to find where the null character is, and then that's going to be my length of my buffers where that null character is. If that makes sense. We'll keep working with the error thing, because before we set anything else up, we need this error thing set up. I'm going to get rid of this C code right here. We don't need that. And the caps lock is on, so it messes me up. Okay, so I'm going to just skip down to the error division where I print the error message, because we can't really set anything up without the errors. I'm going to call this print error. Print error. And you're going to see now the way that we're going to call C code from COBOL. So we use the word call, and then we just put the name of the function in parentheses. So what I want is SDL get error. Okay, and whenever I call anything from C, I'm always going to capture the return, always. Even if it doesn't return anything, I don't care, because sometimes some things don't matter if they return or not, but COBOL will think that the program exited improperly if it gets back something that it doesn't understand. So basically, I'm always going to capture the return from all these, because you'll be building your program out, and you'll be making it, compiling it, running it, and then you get it all works perfectly. But then when it closes, it says it closed improperly. And it was because of one of the information returned from one of the C functions. And it wasn't even a bad thing. It's just COBOL misinterpreted it. So I'm always going to capture in a variable the return from the C statements. So on this one, we do need to capture it anyway, because we need that pointer string. So we're going to capture it like this. We're going to say returning. And it's the error pointer that we made earlier. Error pointer. And this isn't the end of the sentence. What we need at the end here is end call. And I'm going to indent this just for the way I like it to look. So this is calling a C function. And you saw that C function doesn't take any parameters. So this C function is void. It doesn't take anything, but we can tell it to take void if we wanted to, but we don't need to. But it does return this const char, the pointer to a character array. So we are capturing that pointer, not the array. We're not getting the array. We're just getting the pointer. And yeah, so we'll see more complicated ones later, but let's just get this error thing down so we can get further into this code. So that's getting us our pointer. Now I'm going to do that thing where I said I'm going to reset the address of my buffer to this error pointer now. Okay, you can't I couldn't be returning the buffer. That won't work. But I can set the address of the error buffer to the pointer. Okay, so that was up here with this the buff right here that's holding that array inside of it. I'm saying, hey, you know that thing where you know that it's an array and all that? Well, I'm going to actually make the address of that here. The pointer that returned, which is that string. So that string now, I'm going to be able to index through that string, but that array is probably much bigger than the string. So that brings me to the next problem. I need to find out how long the string should be. And this is this perform varying function. So this is the length, what we're putting in here, the buffer length. And this is kind of a loop. So I'm saying I'm using this, and I'm saying from 1 by 1. Okay, so we're incrementing by 1 every time when we're starting from 1. I'm just going to wrap it because the string will go too long. If you don't see a period at the end, it's the same sentence. So like up here at this call, I could make this all one line if I wanted to, but it might be too long, so I can wrap it. But the period is here, so this whole thing is one sentence. This is one sentence. This is a sentence, but it hasn't ended yet. So until error buff array and here's how we're going to index it. So it's one based. So this is our array, and we're indexing it with these parentheses. And I'm going to put the variable above, the error buff num, buff length, sorry, because it starts with 1, and we keep incrementing it until whatever number we end with is going to be the length of our buffer. But right now it's 1, and we're incrementing it by 1 every time. So the first time we come through here, it's 1. So we're getting the first character of our buffer array. And then the second time, we're getting the second one and the third one. Okay, but now we need to find out, we want to say until it equals 0. Now this 0 is not a character 0, this is like a 0, 0. So it's the decimal equivalent. It's the decimal 0, which is going to be the null character. I tried to use the hex version, and it did not work. So just 0 works fine, though. And this is still not the end of the sentence. And we're going to put an or on it so we don't go past our buffer size. Say or error. Oops, that was the first one. Is bigger than 512. So if it hits 513, we got a problem, right? It's going to jump out at 513. Although 513 is okay because it's 1 based. So if our buffer size is 512, the last member is actually 513. So we're looping through this until we find a 0, which is our null character for a string, or until we get to the end of the buffer size, just in case something happens. I also need to put a continue in here, or it's going to complain about it. Now this is the thing that strictly isn't needed, but it is because of the warnings that I have set. And now this will be the end of the sentence. This will be the end perform. Okay, so that's a long one, but that's just basically a loop, and all it's doing is it's going down through through the string and looking for the null character. And when it finds it, that's going to be the number that ends up being from this right here. So now we want to display. So we're going to do this a little bit different too. So the display, like before, display function. We're going to use this function trim because, let me show you in a minute. Trim. And this is the error message that we created, not this isn't the one coming out of here. This is the one that we're going to create. The normal error, not the buffer one. The error message. So the thing is we set this error message to 50 up here. Right here. There's an error message that's the size of 50 that we get to put in our own message. The problem is it will display the whole 50 characters. Even if we just say test, it'll say test, but then there'll be 50, however many 46 more blank spaces, and then there will be the colon, and then the message that we got from SDL get error, and I don't want that. So this trim function shortens it up. It says however long your message is, I'm just going to display that. So I'm going to do the trim, and then I also want to put a colon and a space. So I'm going to do that. So these all happen. This thing will be printed. This thing that's inside the parentheses, the quotations will be printed. And then also, continuing with this sentence, we're going to print the error buffer, that string that we got from SDL get error. So this is the buffer, but we want to print not the whole buffer. We want to print from the first character to the length of what we found above. This one right here. So we found the length of our string. So we want to print our string from the first character to the length of it. And we're going to be putting this upon std error. And then after that, we are finishing this sentence. So I hope that kind of makes sense. We have to set all of this up before we can do anything else, just to get errors out of SDL and to make it all nice and everything else. So we're getting the returned pointer. We are finding out how long the string actually was. And then we're going to print our own message, but trim it. And we're going to put a colon space and then that SDL message that's in the buffer with the length of it. And we're going to put that on the SDL, the standard error out. So it'll be an error message, not just a normal message. And then after this, I'm going to run a code that says clean and exit. We could just put that here real quick. There'll be another procedure here that is clean and exit. Okay. So that'll clean and exit. I think that's the whole thing for this. I know it's quite complicated to set this up. Unfortunately, it's like getting a string out of C into COBOL is no easy task. The really kind of strange setup. So I'm just going to make the other one real quick, the clean and exit. I'm not going to put anything in it. I'm just going to make it exit. So the clean and exit procedure, and it's just going to be a stop run for now. We'll add to it. So that's just closing the program. So it'll be our cleanup, but for now it's just closing the program. Okay, so this is going to take care of our whole erroring thing. Now we can actually start doing something. So the first thing that we want to do is the initialize SDL. So I know we saw that function quite a while ago, but we're going to take care of it now. Here it is, SDL init. It takes our flags. We've already set our flags, and we're looking for the return. Is 0 is good. Anything other than 0 is not good. So our sentinel check is going to be on the 0 or not 0. Okay. So I'm going to make a procedure for this. It's going to be initialize SDL. Okay. And the first thing we're going to do is we're going to call SDL init, but we're going to be using by value the SDL init everything that we created above with the long number in it, or this one, this 62,001. So we're going to say call, sorry. And we're going to say using by value. And this one is going to be so it's just going to send in the number, the actual value of the number, which is it's an int on this one, I think. I'm going to have to double check. I think this both works, but I think this should actually be an unsigned int for this one, but I'm not sure on the other one, but it works regardless. But it might not be perfect. SDL init everything. And then we're going to capture the return. So the returning, and we're going to capture it into a return value that we didn't create yet. So I'm going to go create that return value. We have our error pointer. I'm going to put all the pointers together. And this is just going to be for return values, and they're all going to be kind of binary ints. Binary int with the value 0. Doesn't matter the value really, because I'm always going to be receiving something before I check it. Return value, and then we're going to have the end call. And that is our sentence there. So what we're going to do is we're going to check this return value now. And this is kind of the pattern we're going to see a lot. So we're looking if it's not equal to 0. If return value not equal to 0, then I'm not sure if you can put 0 here. I think you can just write 0 here, but since it's this return value, maybe it's a different type. I'm not really sure. So this is where we're going to generate our own error message and then send it off to the other. So we're going to say move. So we're moving this message into our buffer, into our error message buffer. The one that's not called buffer, the one that's called error message. So that's our message that we want to send, and we're going to send it to error message. And then we're going to perform print error. and then we'll finish the sentence, which will be end if. So this thing, we're populating our own error message into error message, and then we're calling print error. Print error down here grabs our SDL error, figures out how long that, sets the buffer pointer to the same pointer as the error message, figures out how long it should be, and then it prints out our trimmed version of our message with a colon space, and then the actual error message from SDL, and then it cleans up itself. So that's how it's going to go. We're going to do this thing where we do a thing, we check it, and if it goes badly, it's going to exit and clean up the program. That's how we're going to do everything. So this is initializing SDL. Let's close down SDL. So in cleanup, the last thing we're going to do, or well, it'll be the first thing in this time, is going to be the call to SDL quit. We don't need to pass anything in because this is a void function, and it doesn't return anything either. However, I'm still going to capture that. I'm just going to capture everything that comes out of one of these calls to a C function. So we're going to say returning return value, and then just the end of the call. Okay, so this is shutting it down. So we've started it up and we've shut it down, and that's going to be our cleanup procedure every time. So let's try to run this and see if I've actually set up enough stuff going on here. Yeah, I think I have. I don't think it's going to complain about things that we haven't used yet. Okay, it did. An unexpected time. Okay. Oh, okay. We have stuff that we. Where we got these prints at? Right here. So we'll just say perform initialize SDL. Perform initialize SDL, then stop run. Let's see if that's better. Oops. Every time I have the tab on, it's messing me up, or the caps lock. Okay, now what do we got? I don't know this unexpected time. Oh, it's at 23. Okay. Oh, okay. It says time. It should be times. Yeah, it should be times, not time. Okay. That's what it should look like now. The program ran, nothing happened, but it actually should have loaded up SDL and then closed it down. So let's go a little bit further. I mean, we could put a print in to see if our oh, you know what? We probably didn't clean it up because we are just exiting from here. We're not performing. Perform, clean, and exit. Come on now. The caps lock. Okay. I know it's not very exciting. We'll try to push on and get something a little more exciting going on. So we're going to need a window, a SDL window. So we need a pointer for that. We could just take this one right here. It likes to re-indent every time. And I'm going to call this SDL window. And it's going to be null as well. And then we're going to I'm going to close some of these here. Okay. SDL create window is the function that we're going to use. It's going to take a title, which is a string. It's going to take an X and a Y, which is where the top left origin of your screen needs to be. But we're going to use that, the constant that we made that was SDL pause centered. When we send this in for both X and Y, it's going to automatically center the screen for us. And for the width and the height that are both ints, we're going to use our width and our height that we created. And then for flags, I think we're just using 0. Yeah, we're just sending 0 in. So we're not sending any flags in. We are using SDL centered there, and then we're using our width and our height. And we're going to use our title that we've already created as well. So we're going to be calling this function, and we're going to be returning this pointer. And then we're going to check that pointer. If the pointer came back as null, then it didn't work. The pointer didn't get populated, and the function failed. So that's our failure is null, and our success is if we have a pointer that's populated. So we're going to call this function here, and we're going to do it from the initialize right here. So this is our function name. Window, and I'm going to say using. And we need the title. The title we created up here. This one right here, window title. That's the title we're using. Remember, it was we used the Z in front of it to make it a C style string. So we're going to say by content. Window title. Whoops. Window title. And then we're doing the SDL window pause center that we defined up here. SDL window pause center. We're using this twice for the X and the Y. And this is going to be by value. I'm going to indent these later because they're going to keep changing on me. This one here. Twice, one for X, one for Y. And now we're doing the width and the height, and still by value. It's called window. We defined this above as well. Window width. And then window height. And then by value 0 for the flags. But we also want something returned out of this function, which is the pointer. So we say returning, and it's the SDL window. And then the end call. Okay, I'm just going to tab all these guys in. They don't need to be tabbed in. I just prefer it for readability. And it's going to untab that, of course it is. Okay, so this is the whole function. This all lines up with the SDL create function where it needed the title, it needed the X and the Y, and then the width and the height, and a flag, and then it's returning the pointer. And the pointer is already up here, right there. There's the pointer. So now we need to check to see if this failed or not. And we have the pointer, so we're going to check the pointer. We're going to say if it equals null, something went wrong. SDL window. If SDL window equals null, then oops. And then we're going to do the same thing with the error that we did before. I'm just going to grab it. It's the same exact idea, except the message will change. We'll say error creating window. And it's going to do the same thing. It's going to do the whole exactly the same that our procedure down there does, where it gets the error message and it puts it all together and then it shuts the program down. So that is the SDL window. Let's keep moving on to the renderer. So, let's clean up the window first. So for cleaning up, we're going to use the function that cleans it up, which is SDL destroy window. It just takes the pointer to the window and it returns null. So we can do that easily with call SDL destroy window. And this one is using by value. SDL window, and I'm going to capture what's returning out of this. Even though there's nothing, I'm just going to capture it because otherwise you get the funny instances where it says it exited wrongly. I'm just capturing it in the return value. Okay, so that is destroying the window. Okay, so let's go and move on to that is creating the window, that is destroying the window. Oh, that was the render that I just closed, wasn't it? Well, the render is just like the window, except it only takes a window pointer and flags. Oh yeah, it takes 2 flags. Okay. So we're going to use -1 for the first flag. The first flag is the index. We use -1, and it can just grab the first one. And we're going to use 0 for the flags. And window is the pointer, is the window pointer that we've already created above. And this one is returning a heap allocated SDL render. And we got to capture that in a render pointer. So we're going to go up and we're going to make another pointer. And it's going to be the exact same usage. Okay, and we're going to go down to initialize. And it's going to be very much like this. Yeah. We'll say call create, instead of window, it's render using by value, and it's the pointer, or sorry, the window SDL window pointer. So that's what it's taking in as an argument. But then what it's returning is the new render pointer. But we also need two other arguments. We need the -1 for the index and the 0 for the flags. And these are both by value. And then we're returning. And then it's the end of the call. Okay, we'll just put a new line before I do it. And the error check is going to be the exact same as the one above, except it's the different pointer that we're checking. So I'm going to just reuse that and just switch this to render. Render and error creating render. Okay, and then we're going to do the exact same thing with cleaning it up. And I'm doing that last in, first out. So whatever the last thing I created is the first thing I'm destroying. And it's the same, it's the destroy render that we already saw. So I'm going to say call SDL destroy, not window, but render. I'll say by value. There's the render, and I'm going to capture the output again. Okay, add these in. Now we're getting a little bit more interesting. We're not going to see it quite yet, but almost there for seeing something appear on the screen. So let's see if this all compiles now without any major mistakes. Oh, that's pretty nice. I like it. So maybe we should just put a print statement in here to see that everything is being done well. Because we're just assuming it's working, but I'm pretty confident that the calls are pretty simple. Display. Oh, we can fake an error too, but it's easier to do it later when you're loading images. Okay, let's see what that does. There we go. There's our clean. So we know that this is being cleaned up. We can try to fake an error by not giving it the pointer that it wants. Let's say when we initialize the render, we don't give it we give it the render pointer, and it wants a window pointer. We should see some kind of failure here. There we go. Error creating render. That's my message that I created here. And then here is the message that came out of SDL get error. Parameter window is invalid. Because the window, we didn't put in a window, we put in a render here, which is actually just null at the time that happens. So we do know that our error code is working. Just get it back to normal again. And there we go. And let's get on with actually making something appear on the screen. So we have, where is it back here? We created the render and we closed it. The close render is just, I think it's returning void and taking in the render, and that's it for that function. We have already done the get error. We don't need to look at that anymore. We have created the render. Yeah, there we go. Okay, so in order to see a window, we need to actually just delay the program. I think if we just delay the program right now with SDL delay, it takes in milliseconds here, and it's a void function. We'll see a window open, but it won't look correct. And I'm just going to show you that too first. I believe that'll work like that. So we are in the main division, we are initializing SDL, and then we're cleaning up. So here, what if we told it to delay? So I'm going to call SDL delay. And I'm going to say 5,000. That's 5 seconds. Because it's in milliseconds, so 1,000 milliseconds is 1 second. Okay, let's just see what that does. I'm hoping that's going to give us kind of the box outline of a window, but what's in it won't quite look right. It might just show what's underneath it, or it might show it a bit off. So that's what we're going for here. Okay, yep, there we go. We got this outline of a window, but if we were to move it, it doesn't look right. And let me do it again. I'll move it. It's not right because we're not seeing anything. We're seeing what was on the below it. We're not seeing the render. So we need to see the render, we need to clear the render, and then we need to present the render, and then we need to delay the program. So the render is kind of the canvas that we're going to paint on. Whenever we display an image, it's painted onto the render, and imagine there's kind of like two renders. Imagine a painter has two canvases. He paints a beautiful picture, and then he puts it on display in the front window, and everybody sees, walking by on the street, everybody sees this painting that he made. But while that painting is on display, he has another canvas in his back room that he's actually painting on. So nobody sees how long it takes him to paint onto this canvas. He just keeps painting, and when he gets done, he walks up to the window and he just swaps the painting. So for people on the street, it happens almost instantly. The painting goes from one painting to the next painting. But realistically, what happened is everybody was looking at one painting that was already finished, and he was painting on a completely different canvas, and then he swapped them. So this is called double buffer, where you display one buffer while you're drawing on another buffer, and then you just flip the pointers. So what we are going to do is we're going to clear the render, which is our canvas. We're going to clear it, and it's just going to be black. And then we're going to present it. And then we're going to do nothing else. We're just going to let the program sit for 5 seconds. So what's going to happen is we're going to see a black screen. And that's what we should see because we haven't drawn anything on it. We can actually change the color of the render. But for this video, it'll just be black. And we're just opening it up. We're going to show a black window, a black render, which is, what's inside the window. And then we're going to close it down. So that is here, SDL render clear. This SDL render clear, we're not going to worry about the return on this because this thing is going to happen inside of a game loop. And if one of the render clears doesn't work, it doesn't clear, it's not catastrophic to the program. It's okay. It probably will never happen, but even if it happened like one time, you don't need your program to close. It's kind of like if you're watching TV and one of the images being sent to you through the cable line or through the antenna or satellite dish, one of those images garbled, but it happens so quick, 1 out of 60 seconds, you don't need to shut your whole TV off because of it. So for this thing anything that happens in a game loop, I'm not going to shut the game down if it fails. So the clearing of the render, I'm not looking at the return. I'm going to capture the return, but I'm not going to test it. I'm always capturing, but I'm not going to test it for anything. But we do need to send in the render. So render clear, and we're sending in the render. We're going to capture the return, but we're going to do nothing with it. Render present. This one's void. We're still going to capture this void and do nothing with it. And it also takes the render. So the first one is clearing the render. The second one is showing it to us. So imagine this render that the clearing is not being seen at the time. You're seeing the old render version. The render being cleared is behind the scenes, and you can draw on it afterwards. And then we present them, we're flipping them. And then there's the delay that we've already used. Whoops. Okay. So yeah. So render clear and render present, both of them are capturing but not testing, and both of them take the render. Okay, so it's going to be in the main procedure for now, and we're already doing this delay. So above the delay, we're going to say call SDL, is it render clear? And this isn't renderer, this is just render. So there's no two ERs on it. Render clear. So we're going to be using by value, the render. And then we're going to be returning the our standard variable that we're not going to be testing. And I'm going to do the other one too before I even fix the tabs. And this one's going to be SDL render present. And it's the exact same kind of function. Turning, turn value. Okay. And I actually have these broken out into a draw function, which I might as well just do that. So I'm going to put these in their own procedure called draw. I'm just going to cut them, and I will do a perform. Call it draw all. Put that there, put that there. Initialize. Okay. And I'm going to put an exit at the end of each of these. Yeah, just for my readability. So this initialize SDL at the bottom. This one here. This one I have a perform clean and exit. And this one has the stop run. Okay, so I have this draw function right here, or draw procedure, draw all. I'm calling it up here. Okay, so now we should see a window that is open for 5 seconds, and it should be a black window. There we go. And the title should be up here. If you look up here, let me run it again. I'll show you. I have to hover over it, and it says open window up there. And this is going to stay open for 5 seconds, then it's going to close. If you try to close this the way that you close things by pressing, if you have an X in the top left-hand corner of your window or the right, or use a key combination to close things, it will not close. And you might get a message from your operating system saying that the application is not responding. It's because it's not responding. It's not responding to your close request at all. It's opening for 5 seconds and it's closing itself, but it is not listening to your close request. We're going to cover that in the next video. So if you do get that not responding, it's going to close in 5 seconds. Don't worry about that. But it is your operating system is correct. It is not responding to you because it's not programmed to yet. That will be in the next video. So we covered a lot in this video, but basically what we were doing is we have the pointers for our error and then our window and our render. And we've just emulated the constants or the macros that come from SDL for this SDL init everything and this window pause. And these are just our constants, our title of our window, and our width and our height. This is all about capturing that error message, and there's a buffer for our own error message. And here's just a value for the return value from all of our C functions. The main procedure is just calling the initialize. That's where we're initializing SDL. We're checking if it failed. We're initializing or creating the window, SDL create window, and then checking if that failed, and creating the render and checking if that failed. Our cleanup is shutting things down in reverse order. So we're destroying the render, we're destroying the window. This is freeing those resources that they were heap allocated. And then we're shutting down SDL. The error message, we went through that. We're capturing the pointer from SDL error. Then we are mapping that pointer to a buffer, and then we're going through that buffer, trying to find out how long it is by looking for the null character. And then we are printing our trimmed down version of our own message and that version of the error buffer we're printing out, and we're sending it to standard error. Our draw function is just clearing the render right now and presenting it. Anything that we draw would be between these two. When we start drawing stuff, it's going to be between clear render and present render. And right now we are just leaving the window open for 5 seconds. So this is going to close correctly, and if anything error happens, it closes on the error one. So if we go into print error message, this one performs cleanup here. Those are our 2 exit strategies. So I hope that was good enough to kind of explain a little bit on how to open a window in SDL. That is a very long one. I'm sorry about that. There's no way you can you have to bootstrap the whole thing. So unfortunately, it becomes very long, but the next one will be shorter. We've kind of set up the errors and everything else, so we're good. That was 130 lines of code there. So I hope you enjoyed this one. Thanks for watching.